Hello and welcome. In this video, we're going to talk about types of angles. Our objectives are that we can define and identify angles based on their measure, that we can explain and apply the protractor postulate and angle addition postulate, and that we can define and apply congruence for angles, understanding the notation for congruency versus angle measure. So let's go ahead and jump right in. So when we mathematically define an angle, we define an angle as the set of all of the points consisting of two different rays, meaning one direction that we're moving, two different rays, everything between those two different rays that have the same endpoint, and that endpoint is called the vertex. So everything in between those two rays is a part of the angle. The angle is formed by the vertex, which we can see is point A in this case, and the two sides, which are rays, ray AC and ray AB. There are three different ways we can name this specific angle. We could simply call it by its vertex, which is A, angle A. We can do that anytime it's very clear what that angle is. If you look down at this picture below, it would not make sense for us to call something angle Y because there's a bunch of different things going on at the vertex Y. So it needs to be clear what you're describing if you're using just the vertex. The second way we can describe it is by using 3 points, so angle CAB or angle BAC. The order that it is written is the order that you would trace it with your finger. So what I mean by that is CAB would go this way, BAC would go this way. That's still containing all of the same angle measure, but it's showing you which way to go. And lastly, if the angle is numbered on the inside, we could refer to something as angle 1. So those are the ways that we could describe the angle that we are talking about. All of the points that are inside of an angle are called the interior of the angle, and all the points that are on the outside of the angle are called the exterior of the angle. Similar to segments, two angles are congruent if they have the same measure, meaning if they are the same number of degrees, or when we get into the future and we start talking about radians, they have the same number of radians. But two angles are congruent if their measure is the same. And lastly, an angle bisector is an angle that is bisected, or a ray or segment or line that cuts an angle in half, right? The big idea with bisect is that we're cutting in half. Cut in half, or cut into two congruent pieces. So here, this would be a congruent piece and this would be a congruent piece. And we can see that written out over here. We're also going to review some vocabulary from a long time ago. An acute angle is an angle whose measure is between 0 and 90 degrees. I always say it's a cute little angle. Cute little angle. A right angle is an angle that has exactly 90 degrees, usually indicated by a box in the corner. An obtuse angle is an angle that is larger than 90 degrees, but less than 180 degrees. And a straight angle is basically a line. It is 180 degrees. Now, before we jump into some examples, we're going to look at measuring angles using a protractor. So all throughout our math education, we have learned how to measure things in their various ways. If we're measuring weight, we use a scale. If we're measuring height, we use inches. We use a ruler or a yardstick or a tape measure. When we are measuring angles, we learn that we use a protractor, and we will focus in more depth about using a protractor when we get to the constructions unit. But for right now, we really just want to have an angle set up on a protractor and be able to identify that angle's measure because we're going to use the protractor postulate. The protractor postulate basically just says that we can measure an angle. If we place an angle under a protractor, we can measure it, find the exact angle measure using a protractor, and that value will be some number between 0 and 180. So this postulate allows us to talk about angle measure, which is why it makes sense for us to write it down now, which means we should also define the measure. That's the word that we use when we're describing how much an angle is, and we write it in this way, M, and then the angle symbol, and then the letters for the angle we're talking about. So the measure of angle AOB, if we look at this protractor, angle AOB, this can be measured using a protractor. We can tell that this is an obtuse angle. So when we look at the angle measures off to the edge of the protractor, we're looking for the obtuse angle, which in this case would be 140 degrees. So we could say the measure of angle AOB is equal to 140 degrees. And that property is just this postulate that allows us to say an angle has a defined measure, and we can define it using this tool, a protractor. Now let's look at some examples of defining and identifying angles. All right, here in our first example, we're given a lighthouse. The vertex of the lighthouse is M, and then we have boats out here that are at J, K, and L. And we're going to define the 3 different angles being shown. So first of all, in this case, it would not make sense for us to define anything to be angle M because there's a big angle and 2 smaller angles that are being formed at M. So we need to use 3 different letters to define each angle. So we could call the angle JMK. This is the one that relates to boat J. We could call the bottom smaller angle, angle KML, which relates to the boat at K. And the boat at L, we could define angle LMK. Now, each of these could also be the same if we wrote those letters in the opposite order. So I could say this is the same as or congruent to angle KMJ, which is the same angle, just I'm going in the reverse order of the letters. So this angle would also be congruent to angle LMK. And what would this third angle be congruent to? That's right, it would be congruent to angle KML. So for examples 2 and 3, we're given just one angle and we're being asked to give 3 different ways to write that one angle. So go ahead and pause the video, identify the 3 ways to define that angle, and then unpause the video and see how you did. So hopefully you had enough time to complete numbers 2 and 3. Here's the solution for number 2. The most straightforward way to write it would be to write angle Q, but we could also write angle PQR and angle RQP. So there's actually 4 ways we could identify the example in number 3. We could call it angle Y, we could call it angle 1, we could call it XYZ or ZYX. Let's go ahead and look at another example. So here in examples 4 and 5, we're going to identify any angles that have the same measure, meaning they have the same number of degrees. So I can see here that I have 2 65-degree angles, and then I have 2 25-degree angles. And some of you might be thinking that this must be a 90-degree angle, but we're not going to jump that far yet. We haven't identified any of those properties. So we're just going to list those 2 angles together. So go ahead and pause the video and write a congruency statement for each, the pink angle and the green angles. So for the pink angles or the 65-degree angles, we can say angle AGB or BGA is congruent to angle EGD or DGE. And similarly for the green ones, the 25-degree angles, we have angle FGE, or we could rewrite that as EGF, is congruent to angle BGC or angle CGB. Now for number 5, we see the little tick marks, and those indicate angle congruency as well. So we can say angle B is congruent to angle E. Go ahead and pause the video and identify the other 2, and then unpause the video and see how you did. All right, hopefully you had time to do that. Angle A is congruent to angle D, and lastly, angle C is congruent to angle F. Now that we've been working a little bit with angles, let's look at another postulate. The angle addition postulate is going to look and feel a lot like the segment addition postulate that we learned in the previous chapter. What it says is if we have a big angle, that is equivalent to the sum of the 2 smaller angles. So if I have one large angle, I can add the 2 pieces together to get me the whole angle. So if, for example, I knew that this was 35 degrees and I knew that this was 40 degrees, I could add them together to get that the entire angle is 75 degrees. That's what this postulate is allowing us to do. Now let's go ahead and look at some examples where we're using angle measures to find other angle measures. All right, for number 6, we are given that angle LKN is 145 degrees. So that would be this big angle here. Angle LKN is 145 degrees. And we're being asked to find angle LKM and angle MKN. And as usual, I'm going to sort of set this up like a proof because I want us to always be thinking in that way. So what we know is that the measure of the big angle, the measure of angle LKN, is going to be equal to the sum of the two smaller ones. So the measure of angle LKM plus the measure of angle MKN. Now, based on the substitution property, I can plug in what I know to be true. I'm going to come down here with my work. So I know that the measure of angle LKN is 145 degrees. I know that according to my diagram, this angle is 2x plus 10 degrees, and this angle is 4x minus 3. So I started by identifying what I know to be true using segment addition. Then I substituted in what I know. Now I'm going to go ahead and combine like terms. So the left side is going to stay 145. On the right, 2x plus 4x is 6x. 10 plus negative 3 is positive 7. So that was combining like terms. Now I'm going to use the subtraction property of equality to get 138 is equal to 6x, and I'm going to divide both sides by 6 to get that x is equal to 23. And then to find the two angles I was being asked about, I just need to plug 23 in. So the measure of angle LMK is going to equal 2 times 23 plus 10, which is going to be 56. And the measure of angle MKN, I can either do 145 minus 56, or I can just plug in 23. 4 times 23 minus 3, which is going to be 89 degrees. All right, example 7 says, given that angle KLN is this angle here, is a straight angle. Ask yourself, what does it mean to be a straight angle? That's right. It means that it is 180 degrees. Find the measure of angle KLN and NLM. So I'm going to encourage you, start with your segment addition postulate, plug in what you know to find x, and then don't forget after you find x that you need to plug that back in to find the angles. But go ahead and pause the video and see how you can do on your own, and then unpause the video to work through it with me. So here's the segment addition setup. Here's the substitution, and then the combine like terms. Then we're going to use the addition property and the division property, which is going to get us x equals 13. Then we're going to substitute 13 back in to find our other two angles. And there we have it. Let's look at our last two examples and then wrap up this video. All right, for these last two examples, we're going to talk about bisecting an angle. And we know from when we learned about bisecting segments that to bisect means to cut something in half. So if we're cutting something in half, that's going to leave us with two congruent or two equal pieces. So we can start by using the definition of bisect to set up an initial statement. So in this case, our angle PQS is going to be congruent to our angle SQR. And if we were writing this as a proof, we would say the reason here, or the justification, is that that's the definition of an angle bisector, that the angles are congruent. Then to get rid of the congruency symbols, we can say the measure of angle PQS is equal to the measure of angle SQR. And that is true because that's the definition of congruent angles, that they have the same measure. And then we can substitute in what we know. We know that the measure of angle PQS is 24 degrees, so that means that the measure of angle SQR must be 24 degrees. Now this question is actually asking us for the measure of angle PQR, which means we need to put those two together to find the big angle. The measure of angle PQR is going to equal the measure of angle PQS plus the measure of angle SQR. That's the angle addition postulate, which means we're going to be adding our two 24s together, which is going to give us 48 degrees. So the measure of angle PQR is 48 degrees. So I'm going to encourage you to pause the video and try and work through number 9 on your own, thinking about the relationship between these two angles since they are being bisected by this ray QR. And then think about the justification as you work through it. Then unpause the video and see how you did. So we can start by using the definition of bisect to identify our two congruent angles. Then to change the congruency to an equal sign, we can put the measure of angle in front. Then we can substitute in what we know is true for each of these angles. Then we can use the addition property of equality to add 3x to both sides and to add 10 to both sides. And we can use the division property of equality to solve for x. Now this problem is asking us for the measure of angle PQS, which is the big angle PQS. So what I need to do is find the two pieces and add them together, or find one piece and multiply it by 2 because it's a bisector, so each of those angles will be equal to each other. So I can set up my angle addition property, and then I can substitute in what I know is true for each of those angles and combine like terms. And then I can substitute in what I know is true for x. X is 20, so the measure of angle PQS is going to equal 20 plus 120, that is the substitution property. And then if I combine like terms, that will give me 140 degrees. So it's really important in this class to make sure that you're stopping at the place where you have actually answered the question that is being asked in the problem. Let's go ahead and wrap up this video. All right, in this video, we learned about different types of angles. We learned how to classify them, how to use the angle addition postulate, how to identify angles that are complementary, supplementary, adjacent. We used angle bisectors to solve for angles and answer in degrees. Go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.